Hello students, and welcome back to another geometry video. You know what to do. Pause the video, try this problem in your notes, and then unpause it to do it with me. Okay, we are asked to find the values of x and y. If I look at x first, I see that 2x is the measure of angle J. And hey, these red arrows tell me that I'm working with a parallelogram, because the opposite sides, both pairs of opposite sides are parallel. That means I have a parallelogram. And I know the parallelogram opposite angles theorem tells me that opposite angles of parallelograms are congruent. So that means that 2x has to be 50, because the opposite angles need to be the same. So 2x is 50. And if I divide by 2 on both sides, I get that x is equal to 25. Okay, next, let's look at y. Y plus 3 is side LM. And hey, the parallelogram opposite sides theorem tells me that opposite sides must also be congruent. So if LM is y plus 3, that must be the same as kj, which is 18. And if I subtract 3 from both sides, y is equal to 15. Ta-da! Okay, nice review from the last video. Now let's move on to what we have for today. Today we're going to continue talking about parallelograms, but we're going to talk about the opposite of what we talked about yesterday. So, yesterday was, I have a parallelogram, what are the properties? I have a parallelogram, now what do I know? Today, we're not going to write official proofs, we're not going to write rigorous proofs, so don't worry about that. But today we are going to learn, what do I need to have a parallelogram? I could have the opposite sides be parallel, yes. Is there anything else that could tell me I have a parallelogram? So yesterday we said, if I have a parallelogram, then what? Today we're saying, if what, then I have a parallelogram. So we're kind of doing the opposite of what we did in section 7.2. So our learning target is that you know what makes a quadrilateral a parallelogram. So, I know that if I have a four-sided shape, it could be a parallelogram. If what? If what? And our success criteria is that you can prove that a quadrilateral is a parallelogram. We're not going to write rigorous proofs, but you will be able to prove, with a theorem or with something, you'll be able to prove that a quadrilateral is a parallelogram. So, let's review what a parallelogram is. Remember, it is a quadrilateral with both pairs of opposite sides are parallel. Parallelogram. We need all four sides have to be parallel to their opposite side. So 2 pairs of parallel sides. That is what gives us a parallelogram. Okay. Now, this will look familiar, because this is about the same order that we went in for section 7.2, but today, notice it says parallelogram, opposite sides, converse. Not parallelogram, opposite sides, theorem, but parallelogram, opposite sides, converse. Do you remember what a converse is? Think back to chapter 2. We've talked about it since chapter 2 as well. This is similar to what we did in section 3.2 and 3.3. 3.2 was, if I have parallel lines, then what? Consecutive interior angles are supplementary. Alternate exterior angles are congruent. And the next day we said, if what? Then the lines are parallel. We're doing a very similar thing. In 7.2 we said, if I have a parallelogram, then opposite sides are congruent, opposite angles are congruent, etc. Today we say, if what, then I have a parallelogram. So we're switching the if and the then. That's what the converse does, is it takes the if part of the statement, the hypothesis, and the then part of the statement, the conclusion, and we're switching the hypothesis and the conclusion. So, if both pairs of opposite sides of a quadrilateral are congruent, then it's a parallelogram. Then the quadrilateral is a parallelogram. So if opposite sides are congruent, then I have a parallelogram. So it goes both ways. If I know I have a parallelogram, the opposite sides have to be the same. And if both pairs of opposite sides are the same, oh, then this has to be a parallelogram. And you can also prove this with the congruent triangles that we learned about in chapter 5. Okay. So, if that's what the parallelogram opposite sides converse is, what do you think the opposite angles converse is? Well, if both pairs of opposite angles of a quadrilateral are congruent, then it's a parallelogram. So, please put these in your notes. And we're going to see examples of these in just a moment. So, if the opposite angles are the same, I know that this must be a parallelogram. And the same goes for my opposite sides converse. If the opposite sides are the same, are congruent, then I must have a parallelogram. So, with this in mind, let's do our first example. Finding side lengths of a parallelogram. So notice that we don't have any red arrows telling us that we have a parallelogram. And the question says, for what values of x and y is this quadrilateral a parallelogram? If x was what, then I would have a parallelogram. So, and if y was what, then I would have a parallelogram. So, the opposite sides converse says if opposite sides are congruent, then I have a parallelogram. So, if I make sure that x plus 9 is equal to 2x minus 1 and that y is equal to x plus 7, if I make sure that these things are true, then I have to have a parallelogram. Because if opposite sides are congruent, then I have a parallelogram. That's what the opposite sides converse says. The parallelogram opposite sides converse says. So, let's look at these two equations. X plus 9 equals 2x minus 1. I know how to solve this. And y equals x plus 7. Well, I can't solve this because I have a y and an x in there. So I'm going to work with the equation I know how to solve first. And I'm going to get my x's on one side and my numbers on the other side. So let me subtract x from both sides. 9 equals x minus 1. And then if I add 1 to both sides, I have 10 equals x. Awesome. There we go. I know what x should be. Now, y equals x plus 7. I don't totally know how to solve this without plugging x in. So I know what x is. I don't need to try to solve it this way. I can plug x in and say, oh, y is equal to 10 plus 7. What's 10 plus 7? 17. There we go. So if you ever have two equations, one just has one variable and the other has two variables, work with the equation that just has one variable. This just has x's. Then deal with the equation that has two variables, like an x and a y. Okay, so 10 equals x, y equals 17. Let's see if we were correct. X plus 9 equals 2x minus 1, x is 10. Y equals x plus 7, y equals 17. Yeah. That's exactly what we did. And we were correct. Beautiful. All right, now we're going to look at some other theorems. So, first, the opposite sides parallel and congruent theorem. So this is not the consecutive angles converse. We don't have a consecutive angles converse. That's not necessarily true, so we don't have that theorem. But what we do have is if one pair of opposite sides is congruent and parallel. So I have the congruent tick mark and I have the parallel arrow, then the quadrilateral is a parallelogram. So if I know that the side is parallel and congruent at the same time, I don't need to know anything about the other two sides. I know that this is a parallelogram. I know it. And we can prove this. It actually wouldn't be too difficult if we just made a diagonal here. We put a diagonal here. We could prove, using congruent triangles from chapter 5, we could prove that that this theorem is true. So, it's called the parallel and congruent theorem because if one pair of sides is parallel and congruent, then I have a parallelogram. Okay. Make sure that this is in your notes. Also, the parallelogram diagonals converse, so now we're back to the converses. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So in section 7.2, we saw if I have a parallelogram, then these bisect each other. Today, we have if they bisect each other, then I have a parallelogram. All right, then I have a parallelogram. Cool. Let's see an example of these theorems in action. So, example 3, identifying a parallelogram. The doorway shown is part of a building in England. Over time, the building has leaned sideways, so you can see the door. The door is not standing upright. It's kind of like fallen over a little bit, the door. It's leaning over sideways. So explain how you know that SV equals TU. So SV is right here, and TU is right here. So how do we know that these sides of the door, that the left and the right side of the door are congruent or are equal, that the lengths of the door are equal? How do we know that? Well, what is this? What are these markings? I see this yellow upright line tells us that ST is congruent to VU. And look at the arrow, the yellow arrow. This also tells us that ST is parallel to VU. Remember that those two lines sticking straight up means parallel. And hey, so by the parallelogram wait a minute, what's the name? By the opposite sides parallel and congruent theorem, we know that quadrilateral STUV is a parallelogram. So we know that this door is a parallelogram. Is that it? Am I done now? Why do I care that the door is a parallelogram? Well, SV and TU are opposite sides of the door. So because because quadrilateral STUV is a parallelogram. Parallelogram. Opposite sides are congruent. So, SV is equal to TU. Ta-da! So, we had to say, this door, I want to know that the opposite sides are congruent. But how do I know that the opposite sides are congruent unless I have a parallelogram? Well, maybe I do have a parallelogram. And in fact, I do because of the opposite sides parallel and congruent theorem. So, let's check and see if we were correct. ST is parallel to UV and ST is congruent to UV, so by the opposite sides parallel and congruent theorem, quadrilateral STUV is a parallelogram, and then by the parallelogram opposite sides theorem, we know that the opposite sides of a parallelogram are congruent. So, SV equals TU. Yay! We said the same thing. Nice. Alright, now, we are now going to look at the other one. So this is the exact same slide that we saw earlier. The example that we just did focused on the opposite sides parallel and congruent theorem. The problem that we are about to do focuses on the parallelogram diagonals converse. So, just to remind you what that says, if the diagonals of a quadrilateral bisect each other, cut each other in half, if they're the same on either side of the intersection, then the quadrilateral is a parallelogram. So, let's see an example of this theorem in our next example. For what value of x is this quadrilateral a parallelogram? So we don't have the arrows, we aren't told that it's a parallelogram, we're asking what will make this a parallelogram? Well, I can see that the diagonal CE has already been bisected. One of the diagonals is already cut in half. I can see that. But is this diagonal, is FD, has it been cut in half? Because in order for me to be able to use the parallelogram diagonals converse, both of the diagonals need to bisect each other. So, what I would need is I would need for Fn, we would need Fn to be the same as Nd. Then both of the diagonals would bisect each other. So, we would need Fn is 5x minus 8. We would need that to be equal to Nd, which is 3x. So, if these things are equal, then I have a parallelogram, because if these are equal, then the diagonals will bisect each other. So, let's solve and we'll see what value of x makes these equal. Well, what am I gonna do? No, I'm gonna subtract 5x from both sides, because I already have a number over here. We get negative 8 is equal to 3 minus 5 is negative 2x. Then, to get x by itself, I'm going to divide by negative 2. Negative 8 divided by negative 2 is 4. So, in order for quadrilateral CDEF to be a parallelogram, I need x to be equal to 4. Now we can check our answer by plugging it back in. If I plug 4, so Fn is 5x minus 8. If I plug 4 in here, I get 5 times 4 minus 8. 20 minus 8 is 12. So if x is 4, Fn is 12. Now, Nd is equal to 3x, and if I make x 4, I get 12. So yes, these are the same, and they are indeed bisected, or they have been bisected. This diagonal has been bisected, so we were correct. X equals 4 does work, and it does show that both diagonals have been bisected. So, by the parallelogram diagonals converse, we know that if X is 4, quadrilateral CDEF is a parallelogram. Let's check and see if we were correct. F minus X equals 3X. X equals 4. They solved a little bit differently than us, but that's okay. Both of us did it, in a mathematically correct way, and we both got the same answer, X equals 4. So quadrilateral CDEF is a parallelogram when X is 4. Yay! All right. So, a little summary. All of the ways that you can prove a quadrilateral is a parallelogram. That you can show, yes, this shape right here, whatever shape we're talking about, this is a parallelogram because... So you can show that both pairs of opposite sides are parallel. That's the definition of what it means to be a parallelogram. You can show that both pairs of opposite sides are congruent. That's the opposite sides converse. You can show that the opposite angles are congruent, which is the opposite angles converse. You can show that one pair of opposite sides are congruent and parallel. That's the opposite sides parallel and congruent theorem. You can also show that the diagonals bisect each other, and that's the diagonals converse. I also really like that they give us pictures of what each of these looks like. So if you can show these arrows, it's a quadrilateral. If you can show these tick marks, it's a parallelogram, it's a parallelogram. If you can show these angle markings, it's a parallelogram. If you can show, etc., etc. If you can get this picture on the right, then we know that we have a parallelogram. So, be sure all of the things in blue here, all the words, the names of theorems in blue, be sure that you know the names of those, because some of your homework questions might call for that. Okay, that is what I have for you today. So, now is the part of the video where it's time to rate yourself. Assess your understanding of the learning target and the success criteria. So, do you have the light bulb? Are you a 3 and this totally makes sense? Do you have the question mark and you're a 1 and you're confused? Or are you somewhere in between these two folks? You're like, I might have some questions, but I think, I also have a light bulb on some of the stuff. Where are you? Do you know what makes a parallelogram a parallelogram? And can you show that that a quadrilateral is indeed a parallelogram? Can you prove it? Can you use the theorems that we learned about today to solve problems? So, rate yourself and take the appropriate action. Ask questions, help your friends, try the homework. Speaking of homework, this is not necessarily your homework, but these are some practice problems that you can do to practice the skills that you have learned in this video. So, and notice how it says state which theorem you can use. So that's why it's important to know the names of the theorems and what each theorem says. So, try these, practice the skills you've learned in this video. Now, let's end our video with a launch, just like usual. So this launch comes from an anonymous source, but it says, when you love what you have everything you need. Do you love what you have? If you do, are you content? Do you find that you're content? You're not really searching for anything? You don't need anything else? And if you don't love what you have, do you find that you need something more? So, what this is saying is what a lot of our launches are saying. It's all in your attitude. If you choose to love what you have, you're good. You have everything you need. If you decide to pick out the flaws in what you have or find the negatives of what you have, you're gonna want something more, or you're gonna feel like you need something more, even if you don't. It's like with Mr. Dodge. If I focus on what I love about him and how much I love him, I'm good. If I focus on, oh, the little things that, like, maybe that one little thing I don't like, if I focus on that, well, oh, I need him to change. I need him to fix that. No, I don't. I can focus on what I love so much, and I can focus on why I love him as a whole instead of trying to pick apart every little thing. And that doesn't just go for relationships, right? That goes for anything. That goes for the phone that you have. It goes for the home that you're living in. It goes with the friend group that you're a part of. It goes with anything. If you love what you have, you'll be content. You'll have everything you need. So, that is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thanks for being here. Thanks for watching. Bye.